So now we're going to finish off what we started. Now you really shouldn't be looking at this unless you giving it a good go. If you're just copying this down, like I'm strongly recommending not doing that. You should be struggling with the code yourself. Okay, so let's finish off what we started. So we got the thing written. We might just record those slopes here. Yeah, so here's the slope of V and here's the slope of T. So they're there. So we've done that first bit. We've done the guess for V. We're going to start with V equal to 18, which is shooting straight at it. And now I think we're into the code. So I'm just gonna do Euler's method rather than kind of complicating it. If you want to give it a go at one of the more complicated ones, give it a shot. And if you have any questions, you can submit your file and we'll work from there. So off we go. So we have dim dBl x as double, dim dBl t as double, dim dBl v as double, dim int row as integer. And I want to save this as perhaps int, right. Saving always before you run code. Come back. So initial values then. So dBlx equal to 0, dBlt equal to 50, dBlv equal to 18. We'll have now we might change from 25. We'll see how it goes. Int row equal to 2. Do. So I want to do the printing. So it's going to be cells int row 1, column 1 for x, int row 2 for column t. And you could actually, looking at this, you could kind of define your variables to be variables 1, 2, 3, and then you do this printing with a for loop. Okay, so now the next values. So x is easy, dBl x, it's dBl x, and then the h is just 0.01. No need to put, you can put a h up there if you want, but I think I'm just going to put it in like this. dBlt is equal to dBlt plus 0.01 times dBlv. Now once execute, so now after this line, t is the new t. So what I'm going to do is I'm going to take the old t from here. Okay. And I have dBlv equal to dBlv plus step size. And then that uses printed old printed t. Okay, put up the row. Something like a like must be some kind of a command. So until dBlx is greater than 5.1, I'll try 5. Let's see how it goes. Okay, so save before I run. Bombs away. So what I need to do is I need to record the t value at 5. And you can do all kinds of things here, you know, about a message box, but I'm not too worried at this point about that. Yeah, so I'm looking at, I'll take that a precision 159.3393. Now I had said previously, now that's actually an overshot. Let's have a look at the curve. That's an over, oh, that's a little weird, isn't it? (90/5) is, yeah, so I'm surprised that that it's given me an overshot. We'll carry on, it's just, it's a little bit weird. And I'll just check a sign. Yeah, I can't explain it too much myself. Yeah, we'll just assume everything is in order and we'll keep on going. So that's gone bigger than 140, so I need a smaller slope. So I'm not going to do 25, I'm going to try 10 now. Okay, so change, so that didn't work. Now you can run with 25, you can have 2 overshots, that's absolutely fine, but it doesn't make as much sense. Syntax error. Oh, yeah. Now you see you're getting an undershot. Okay, so what's it giving me? Again, maybe it'd be nice to do this with a message box. We'll kind of keep it simple in the way that I want the focus to be on the shooting method. So now I can use the formula, right? So I've got, let me look at we'll do two different ways, right? So the first way, which I like, is I have an overshot and an undershot. So, overshot, undershot. So I'm trying to hit 140, and with a slope of, which was VB, I think, equal to 10, I ended up with 115.9433. With a starting slope of 18, I got 159.3393. So this is where I'm at. So what I'm going to do is I'm going to start with the slope of 10, and I'm going to take a certain proportion of the difference in slope, which is 8. So this is kind of the intuitive way of doing it. So the correct slope should be the bottom slope, the undershot, plus what proportion? So the proportion of the difference, which is 8, should be the proportion of 140 to 115 out of 115 to 1593. So maybe this will make more sense for you with the formula. For me, this makes more sense. So I definitely want a calculator here. So the proportion is 140 minus 115.9433 out of the total distance between them, which is 159.3393 minus 115.9433. So that's a proportion. This distance as a proportion of this distance, that's that, of the difference between the slopes, which is 8. And so I get 10 plus 140 minus 115.9433. Of course, again, a lot of this calculation can be done in the VBA, but I think it's, and you might like to do that, but I think it's, just to understand the shooting method, it's better just to do this bit by hand, maybe initially. So it comes out as 14.435, okay? And I'm going to run it again and see what happens, except with that slope. So finally, V0 equals 14.435. A little bit embarrassed if it doesn't quite work, of course. So if I run it here, look, it's hitting it up to a rounding error. And here it's working perfectly. Now those of you who might be a bit flummoxed by, what are you talking about averaging? Here's the formula, and that's actually pretty much exactly what I put in. So I'm just going to label things. This was the VB. Now the Y of X1 is what you're trying to hit, which here would be the T5. And then we have the TB, which was our second shot. So I'm not writing Y's, I'm writing big T's. TA minus TB. And then the slope here is the difference between the slopes, VA minus VB. So you can maybe pause this and just see that it is actually the same thing as that formula. So you just need to understand in that formula, the VA and the VB are the two slopes. The YA is the first shot, trying to hit 140. The YB is the second shot, trying to hit 140. And the Y of X1 is actually the 140 that you're trying to hit. And so we're done. So yeah, the obvious way to make this better is to use Heinz method, etc. But I'm quite happy just with you understanding this much. So this is temperature versus distance. I'm a bit confused the way that, yeah, okay. Right, so now the goal seek is great crack then. So what we want to do here is, so we need to do the Euler for V. Now we've written the differential equation here for V. Now the 5 by 10 to the minus 8, you have to be careful with brackets, etc. We'll give it a go. So equal to previous V, which is this, plus step size, which is 0.1, times So what is that derivative? 5 by 10 to the minus 8. So 5 times 10 to the minus 8. There's probably some other buttons you can use like exponential, but that should do it, hopefully. Times 5 minus t. That should be the previous t, which is this, to the power of 4. And that should do it now. And now I can just do that. So what are we trying to hit here? We're trying to hit 140. Well, that's not working, is it? So as I said, we're trying to hit 140. God damn it. Don't know what it doesn't like. Oh, it doesn't like that. So we're trying to hit 140 and it's an overshot. Now we can't do an undershot because the differential equation isn't linear with that power of 4, so we use goal seek instead. So it's data, what if analysis, goal seek. So we want C62, so that's B62. So that's the temperature at x equal to 6. We're trying to hit 140. Where's that 140 coming from? Here. And we're going to do it by changing the initial slope, which is C2, not C3. So you're going to see it going, you're going to see some crack. Oh, I missed it. I want to do it again, but I missed it. Okay, now you might get slightly different values here because there's an element of randomness and like, does it hit exactly 140? It's a good question. I don't know, does it? Maybe it does 1,000 times that number. How about 10 to the 8? Yeah, you see there is some rounding error in there, right? But don't worry about that. So you might get slightly different figures here. So here you go. Yeah, that's it. So if you did those, I'm going to be putting in some exercises, answers to, I suppose, these two, whatever, but you can look out for the announcement for that. Okay.